Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue Dave's defect with a most challenging problem, baggy webs. This defect may be one of the top 3 causes of waste, delay, and customer complaint in the collective web industries. I know your time is precious, so let's get started. B is for bad. B is for baggy. No doubt, bagginess is quite troubling for customers and suppliers alike. It causes a wide variety of aesthetic, runnability, and wrinkling issues. No less troubling is the difficulties for troubleshooters. This defect is hard to measure, hard to fix, and the failure rate is quite high. As I teach in the wrinkling module of my Web 101 class, this is one problem that you do not want to raise your hand for. Oh, too late, you say. You got volunteered or voluntold by your boss. Yet, there is good news. A lot of good news. That is because baggy webs are one of the best documented of defects. I have about 30 Web201 clips on how to troubleshoot and treat baggy webs on this all web handling channel of YouTube. Also, I cover baggy webs in my award-winning and trademarked Web 101 class that has been taken by 5,000 students just like you. This class is available as video-on-demand training in the U.S. through AIMCAL's Converting School Online, in Australia by Apita, and in the U.S. by Tappy. So, before you do anything else, go to school. Take the Web 101 class and then view all of the baggy web clips on this channel. You will need this kind of background to tackle this most challenging defect. Then you are ready to begin troubleshooting. Here, a clarity of goals is essential. Your job is to find out which element of which machine owns the CD lane that caused the profile variation of the web, which then caused the baggy web. That profile could be owned by formers such as film extrusion, foil rolling, or paper making, or some other web maker. That profile could be owned by converting processes such as calendar encoding, printing, and so on. Troubleshooting will go far beyond merely making lists of candidates that might cause bagginess. Lists are lazy troubleshooting. You want to find the root cause, not a possible root cause. See my troubleshooting books, columns, and clips for ideas on how to do this. You will know when you got the right answer, when you can point to the offending element via several lines of reasoning and manipulate the shape of that element to change the bagginess profile. If you can't do that, you may need to do more work. At the great risk of jumping to conclusions, most bagginess is caused by web formers or web converting processes that make an uneven thickness profile. This extra thickness in one lane builds to be a very tiny ridge of extra diameter, which then stretches the web into bagginess in the wound row. In other words, flat in, but with varying thickness going in, baggy going out. While winding looser helps, this may not be nearly enough. If you start playing with curves or taper, you are lost. All you need to do is to wind so loose that is painful. Do this by reducing all of the TNTs as low as they will go, and then some. It is quite possible that winding looser will not be enough. But again, please don't play with curves. If winding as loose as possible is not enough, then you must go and solve the root cause thickness variation coming from upstream. You must identify the specific element that is responsible and redesign or maintain that specific element to be less variable. It matters not to the winder whether you can measure the thickness profile variation by lab test, $1,000,000 online scanner, or any other instrument. The wound roll will make its own judgment on how good your web is. The variation of thickness that caused the bagginess is quite small, perhaps in the range of 1%, where you could have few problems, to perhaps 10%, where you will have few commercially acceptable products. Yes, you can take a bit more with blown film because it's oscillated 360 degrees. Yet foil is even fussier than this 1 to 10% range. The challenge is that the size of this variation is so small that it is barely detectable by common measurements. On thin webs, this may be immeasurably small. On some products, most notably paper and some harder grades of film, the thickness variation is sometimes easier to see as a delta of roll hardness. We covered those methods in great detail in my Web 101 classes that is also thoroughly documented in the literature. It is quite reasonable to ask for tricks to run baggy webs. We cover that in great detail in my Web 101 class. There are none. All you can do is to not make the problem worse by poor machine design and poor machine maintenance of both mechanicals and controls. Once you are certain, as any troubleshooter can be, that you have identified the specific offending element that caused that profile variation, the next step is to level that element if you own that element, or complain to the supplier if you are getting bagginess from some upstream process. I teach how to complain in my Web 201.22f clip. If you are not effective in complaining, or the supplier is not responsive, or if this is beyond your pay grade, you can expect to suffer from bagginess forever. I have given you what I think are the best online resources for baggy web troubleshooting. However, some people may wish to dive even deeper. Here you could simply go to the free Roysum Library database by Abbott App. You will find no less than 74 articles, columns, conference papers, and other publications on this specific subject. However, I would like to call attention to 3 that I believe were the most influential. One of the earliest treatments is my paper on baggy webs. A decade later, 2 extremely talented women took the science much further. I was an industrial advisor for Cecilia Land's PhD thesis on baggy paper. She confirmed the nearly immeasurably small variations in thickness that were responsible. Most recently, Amy Tour of Avery Dennison taught us how to screen bagginess coming from your supplier using roll hardness, perhaps without even needing to take the roll out of the package. Thank you so very much for joining me in this defect solving and defect preventing series. Stay tuned for the next clip where we will discuss another of my favorite defects, blocking. If you found anything interesting or useful here, please like and share and subscribe. Also, please consider supporting the work of this channel using the Patreon link below. See you next time.